Hi everyone, I'm Samuel Dubois from the Belgium Building Research Institute. Today I'm going to present some insight on the drone technology and more specifically about reality capture, meaning how to capture reality and transform it into 2D or 3D information. So what are we doing? We are a small lab within the BBRI. We are the lab of retrofitting and heritage. And several years ago, around 2015, we used a lot of subcontracting to do drone mission. We needed to have high definition surveys of buildings, and we got used to call some men to fly around this building to do 3D scanning. Some years later, now we have our own devices. We were licensed to fly, and we got used to the 3D technology. So a bit about context about drones and reality capture. So digital construction is basically a bunch of new technologies that are working together to make the work more efficient and to better understand the building and how to enhance them. And one of the common points of all this technology is to work with 3D data. So reality capture is basically transforming reality into information, into usable information. And you have of course, two categories of information, 2D and 3D. Imaging technology will produce pictures, so 2D data, and 3D scanning technology will produce point clouds or these kind of high resolution solution. So we are in the point cloud era, meaning that we are able to really capture these kind of highly realistic data. It means that the modeling effort are really lower than before. We are directly getting this kind of information. And of course, it's not only about visual information, it's also about technical data. And we have been working a lot on how to transform this point cloud, for example, into technical retrofitting data. And this is an example of a church where you see that we highlight the planarity of the walls using specific algorithms. More than technical data, it's of course a lot of new ways of communicating between actors. Here it's an interesting example where we just put a 3D model within PowerPoint. So we were able really to manipulate this 3D model and to show, it's just a basic example, but we are able really to provide some animation on a 3D model within PowerPoint. And it really shows that even using these kind of old tools or traditional tools, we can still benefit from this new scanning technology. And we can, in this example, highlight, for example, some damage on a facade. And everyone is used to PowerPoint, so it's a better way of communicating than using sometimes like complex 3D processing tools. So we saw that there are many usage to 3D data, and 3D scanning technology will produce different kind of 3D models. And it means that there are a bunch of new representation of reality. And it's really important for professionals to understand the difference between, for example, a point cloud or a BIM model, which is the two extreme that we could consider when we do 3D scanning. A point cloud is really raw scanning data. It's what's produced, for example, by a laser scanner. It's really highly accurate, a lot of information, but it's sometimes difficult to read. It can be really large file, difficult to open, and difficult to get access to the useful information. On the other range, a BIM model implies a lot of modeling effort. It's really readable because all useful information can be included in the model. You can click filter according to different kind of construction elements. So it's really readable information, but you will lose a lot of information about geometry, a lot of details of the model. So knowing what kind of model is the best solution for a need is really crucial when you do 3D scanning. So what about photogrammetry and drones? Photogrammetry basically is one of the technology that allows to create 3D data when using drones. And the principle is basically to use picture with a high overlap value to guess the shape, the 3D shape of the object that you photographed. And it's an indirect way of scanning a building, because laser scanner, for example, we directly record the building in 3D using some LiDAR technology, whereas photogrammetry, it's an indirect way of producing a 3D model, because you will first get pictures and then you will import this picture in a software, and the software will reconstruct the model in 3D. So what's important to understand is that you have, thanks to drones, you have access to a wide range of interest objects. You can start with a wall, a roof, so small scale envelope elements, but you can go up to the site level or even the district or the city level, because it's able to fly really far. You can take distance to the object. So it becomes really useful when you have to, you want to have these large case studies. And the type of data that you will produce is image, basically, but not only color image, also thermal image or multispectral image, for example. Working with videos is also possible, and you can produce a 3D model based on a video, but the problem there is that the resolution of a video is always lower than photographs, so you will lose some details in your model. So what does it look like in the software? I know a lot of you know that quite well, but it's sometimes good to go back to the basics. So you take a lot of picture on site, then you import all of the picture in a software, and you can see that the software on the right picture will guess the location and the orientation of each camera, meaning each photo that you took. And guessing the orientation and location of a camera will, in a second stage, allow to produce this high definition kind of 3D model. In that case, it's a mesh, meaning that it's really like a video game element, a high definition representation of reality. I don't have the time, of course, to go into details regarding the technical aspect of photogrammetry, but if you have to remember one aspect of photogrammetry, it's the link between the image and the accuracy or the resolution of your model. Meaning that if you scan a highly textured model, a highly textured building as a church or any kind of heritage building, you will get a lot of details on the picture. And the details that you will be able to get from the software will depend on what's on a pixel of your picture. You can see there on the top that on that example, you have some limit to your image. You will get at some point to the pixel size of your image, and you can see that it's in that example it's enough to get a reasonable amount of details on this church. So really, this link between picture and resolution and accuracy of the model is really important. And because it's based on picture, it's a picture processing, you can get access to this highly, this wonderful level of textural quality. It means that not only you have your 3D information quite impressive, but also this texture that can be put on your 3D model. And of course, using this kind of model is really useful for inspection, for example. So why drones are so useful when you do photogrammetry is, of course, to get access to difficult place where it would be difficult to take photograph, so a highly elevated place, for example. And in that particular mission, it was almost impossible to get access to the building. It was this old ruin in France, and we had to use drone to take picture to this building, because from the ground you wouldn't get a nice image of this ruin because of the trees, because of all the obstacles that you found on the way. So there, flying even with a small drone is really useful, and it's really valuable when you do 3D scanning. And on the right, you can see the high level of details that you can get using photogrammetry. Each stone can, of course, be modeled by the software. So to conclude here, some examples that are the work that we do on the lab of retrofitting and heritage. So what's important to know is there are a lot of final users to the 3D scanning mission, and it's always good to ask yourself, what's the useful information? Which is the useful information that you want to get from the scanning mission? And knowing that, you will find different workflow of data transformation, and each workflow is adapted to one specific need. So what are those needs? The most common need using drone and photogrammetry is visualization and documentation. For that, you can get videos, you can get auto views of your model, you can produce this mesh that we just saw. There are a lot of visual information that you can get with drones. Here, I think it's a good example, again, with the same church. When you see that we flew with a drone, you can get access easily to good top-down picture. You can get a lot of details from close to the church, and then you can import the mesh into video game engine, and producing this kind of really appealing documentation of the building. You get almost like a video, but except that you can change the point of view, you can get access to a lot of information. So it's about documentation, it's about marketing, but all of that only comes from drone pictures, basically. Another kind of mission that you would have is, of course, measurement. Drones, photogrammetry allow to get precise geometric reconstruction of buildings. So there you will use more technical data. And one good example is facade, for example, where we add these stories of prefabricated elements. And for retrofitting building with prefabricated elements, we needed to have a highly precise representation of the facade. And the other drones are a good solution to have this low-cost access to planarity. Of course, there you have to process the data in a good way so that it becomes readable for the people doing wood construction. And it means that the point cloud, the full resolution point cloud, is not always the good solution. And you have to process the data to have something really directly understandable by people doing this kind of work. A wide range of studies, of course, are related to inspection. And there, the example that I choose is linked to thermal image, because not only color information can be captured with drones, but also different kind of spectral information. So there we flew with a drone around a district, and we took color picture and thermal picture. And by doing that, and by performing photogrammetry with when we got the picture, you can produce this kind of thermal mesh. So it means 3D data where you can actually see where the thermal defects are located. And this kind of processing is quite new, and it's again really valuable for the professional. But it also means that you need to process the data in a good way. So all of that make me ask a question: why requiring high definition survey? So when do you need to get this high level of geometric details and high level of textual details? And it also means that you need to specify a mission in terms of deliverables. It means that depending on the need, you will have different kind of answer to those needs, and each answer, it's an actual workflow between from the site data up to the final deliverable. So at the BBR, we worked a lot on those workflow, and we tried to really provide some ID card of a project, meaning that for each mission, we have a typical workflow starting from site data up to what we call shareable deliverables. It means that most of the people, they do not need to have the actual point cloud, but they would prefer to have this process point cloud, meaning image, auto views, or even virtual visits of the model. And this notion of data transformation is really useful. There you can see really the digestion of data, starting from the raw data, then cleaning the point cloud, and then producing these views of the roof. And in that example, the final lead was to evaluate the state, the condition of the roof. So to conclude my presentation, I think you saw that there are many possibilities with this modern technology. It's really impressive, the quality of data that you can get, but you also have more and more data to manage. And it's not always good, because there is a tendency to share this high definition point cloud between all actors around the building. And it's not always useful. And this notion of workflow and final deliverable is really crucial. So now, if there are two needs to define, the first need is better mission specification. So really describing a need in terms of technical data. And the second need will be, of course, to have better data extraction tool. And there you have, for example, AI that comes into my mind. So these two goals, I think, would be in the center of a lot of studies to come. So that brings us to the end of my presentation. Thank you very much for listening to me. If you have questions, comments, or you want to collaborate in a way or another, you can always contact me at my mail address. Thank you.